amazing people, students, lovers of chemistry out there. I'm here once again and I'm super excited to be with you on this episode where we balance a chemical equation yet again using the algebraic method. My name is David, the billionaire teacher who takes the mystery out of chemistry so you can make history. And on today's episode of balancing using the algebraic method, we have been asked to take care of this chemical equation. So let's go into detail step by step, do justice to this, and then we'll draw the curtains on today's video. So the first thing to do, as usual, in balancing a chemical equation using the algebraic method is to assign letters to represent the coefficient for each compound. So here's what I mean. We have the first compound Al₂, SO₄, 3. There is a particular coefficient that should stand in front of this compound in order to balance it. And that coefficient will be represented by a letter. Let's represent it by the letter A, since we do not know what the coefficient is. And then we have the next compound, which is CaOH2. So let's represent the coefficient using the letter B. And then thirdly, we have AlOH3. Let's represent this coefficient using the letter C. And then finally, we have CaSO₄. Let's represent the coefficient using the letter D. I'm sure you saw how each and every coefficient was represented appropriately using letters. The next thing to do is to form equations for each letter. Now, here is what I mean. We have a number of elements and polyatomic ions. Okay, so let's deal with them individually. The first element we have is aluminium. On the left hand side, you can see aluminium stands here, having a subscript of 2 and a coefficient represented by the letter A. So that tells us that the number of atoms of aluminium on the left hand side will be given by the subscript 2 multiplied by the coefficient, which is A, and that gives us 2A. Did you see how that was done? I'm sure you did. The next appearance of aluminium is on the right hand side. You can see aluminium having a subscript of 1, even though that 1 is not identified, and then a coefficient of C. So that tells us that on the right hand side, the number of atoms of aluminium will be given by C multiplied by 1, which gives us C. And according to the law of the conservation of matter, the left hand side must be equal to the right hand side when you're balancing a chemical equation. So that simply tells us that 2A has to be equal to C. This is the first equation. Did you see that? The next element or polyatomic ion that we have in this chemical equation is the sulfate ion SO₄. You can see it appears on the left and it also appears on the right. And when you are balancing a chemical equation that has a polyatomic ion, you treat it as an individual unit. So we have SO₄. On the left hand side, you can see SO₄ has a subscript of 3 standing outside the bracket. And the coefficient that stands with the compound is the letter A. So that tells us that the number of times this polyatomic ion appears will be given by the subscript 3 multiplied by the coefficient, which is A. That gives us 3A. On the right hand side, you can see SO₄ over here. And SO₄, if you bring it out like this, it has a subscript of just 1, or it appears only 1 time. And then the subscript or the coefficient attached to it is the letter D. So that tells us that on the right hand side, the number of times SO₄ appears is given by D multiplied by 1, which is equal to D. So equating the left hand side 3A to the right hand side gives us 3A is equal to D. This is the second equation. The third element that we have is the element calcium, Ca. Calcium appears just once on the left hand side. You can see over here calcium has a subscript of 1, even though that 1 is not shown physically, and a coefficient of the letter B. So the number of times that calcium appears is given by B multiplied by 1, which gives us B. On the right hand side, you can see calcium over here having a subscript of 1, even though it's not identified, and a coefficient represented by the letter D. So on the right hand side, the number of atoms of calcium that we have will be given to us by D multiplied by 1, which is equal to D. I'm sure you saw how that was carried out. So therefore, if the left hand side is equated to the right hand side, the equation now becomes B is equal to D. This is the third equation. And then fourthly, we have the hydroxide ion, OH. On the left hand side, you can see the hydroxide ion covered in a parenthesis, and the number of times it appears is given by the subscript of 2. The coefficient attached to it is the letter B. So the number of times the hydroxide ion appears is given by B multiplied by 2, which is 2B. On the right hand side, you can see the hydroxide ion over here. It has a subscript of 3 and then a coefficient represented by the letter C. So that tells us that the number of times it will appear will be given to us by the subscript 3 multiplied by the coefficient C, which gives us 3C. So if we equate the left to the right, it gives us 2B is equal to 3C. This is our fourth equation. So we have all 4 equations generated now. Let's write them out step by step. At this point, we have all 4 equations written down. The next thing to do will be to pick any letter. We can pick any letter arbitrarily and assign a small whole number to it. So let's pick the letter A, for instance, and assign the number 2. So that means anywhere we see the letter A, we'll write the number 2. For the first equation, we have 2A is equal to C. So using the number 2 to represent the letter A, this gives us 2 multiplied by 2 is equal to C. C therefore becomes 4. So we have A being equal to 2, C is equal to 4. The next equation says 3A is equal to D. Now we know the value of A to be 2, so that therefore becomes D. So we have D is equal to 3 multiplied by 2, which is 6. So we have the value of D to be 6. That's for the second equation. The third equation says B is equal to D. B is equal to D, and we know that D is equal to 6. So therefore B automatically becomes 6 as well. So we have B is equal to 6. And then finally, we have the last equation that says 2B is equal to 3C. B is equal to 6 and C is equal to 4. 2B now becomes 2 times 6, which is equal to 3C. C is equal to 4. 3 times 4. 2 multiplied by 6 gives us 12. 3 multiplied by 4 gives us 12. So we have the values of all letters given to us. The next thing to do now will be to use the numbers that we have identified the letters to be to impute them into the equation. Let's do that very quickly. To do that, we have the original equation that says Al₂ SO₄ 3 plus CaOH2 yielding AlOH3 plus CaSO₄. Now if you recall, you'd remember that we used letters to stand in front of each compound. So now we can use the numbers that represent each letters to impute them into the equation. So the first letter, I beg your pardon, is A is equal to 2, B is equal to 6, C is equal to 4, and D is equal to 6 as well. So this equation now becomes 2Al₂ SO₄ 3 plus 6CaOH2, and then we have 4Al₄ plus 6CaSO₄. You can see how this was carried out step by step. At this point, we can say this is our final balanced equation and it will be correct. But if you notice very well, these coefficients are not in their lowest term. In other words, there is a number that can divide all of them, and that number is 2. If we divide this coefficient by 2, we have 1. Divide this coefficient by 2, we have 3. Divide this coefficient by 2, we have 2. And divide this coefficient by 2, we have 3. So our final balanced equation becomes Al₂ SO₄ 3 plus 3Ca OH2 yields 2Al OH3 plus 3CaSO₄. This, ladies and gentlemen, is our final balanced equation. Now, to be double sure and certain that we've not made any mistakes, we're going to do a quick rundown check to see if each element coincides from the left to the right. So here's what I mean. For the first element, we have aluminium. Aluminium on the left hand side, you can see it appears here, and it has a subscript of 2. Aluminium appears twice on the left. On the right hand side, you can see aluminium having a coefficient of 2, which tells us that aluminium is balanced on both sides. The next unit we have is the polyatomic ion SO₄. SO₄, you can see over here, has a subscript of 3. In other words, it appears 3 times on the left hand side. On the right hand side, you can see SO₄ over here. There is no subscript attached to it. In other words, its subscript is 1 and a coefficient of 3 is attached to the compound that carries it. So that tells us that it appears 3 times as well. So SO₄ is balanced on the right and on the left as well. The third element we have is calcium. Calcium, you can see over here, has a coefficient of 3, which tells us that it appears 3 times on the left hand side. On the right hand side, the same thing applies. Calcium also has a coefficient of 3 as identified over here. So calcium is also balanced. And then finally, we have the hydroxide polyatomic ion. The hydroxide polyatomic ion over here has a subscript of 2 and a coefficient of 3. So that tells us that 2 multiplied by 3 gives us 6 times it appears on the left hand side. And you can see on the right hand side, the hydroxide polyatomic ion has a subscript of 3 and a coefficient of 2 over here. So that tells us that it also appears 2 times 3, which is 6 on the left and 6 on the right. So this equation is fully and properly balanced. So writing it out one more time for the sake of clarity, we have Al₂SO₄ 3 plus 3Ca OH2 yielding 2Al OH3 plus 3CaSO₄. I'm sure you saw how this equation was balanced step by step from beginning to the end. If you enjoyed this video, please do well to like it, subscribe if you haven't, and share to as many people as you can. And don't forget to turn on the notification bell icon so when more educational videos like this come out, you'd be the first to be notified. It's been a pleasure serving you with my gifts, potentials, and everything that I've got. My name one more time is David, the Billionaire teacher, and everything I do here is to take the mystery out of chemistry so you can make history. I look forward to seeing you in my next videos where we get to solve more mind-boggling chemistry questions. Up until then, I'll see you in the next video.